Okay, how fast is the balloon rising? At 120 seconds. So I look at 120 seconds. How fast it's rising would be elevation. So I want to estimate approximately how fast. So I would either use 120 to 750, and I could use either the point below, which would be this one, or the point above, which would be this one. Either one, because they're both 30 seconds away from each other. I'm sorry, not 30 seconds away from each other, but 30 seconds away from 120. So either one would be fine in order to get an estimate. So that's going to be 2750 minus, and I'm going to go ahead and just use the 90 seconds. So minus 2350 over 120 minus 90. So again, I would use the you're trying to figure out at 120, so use that as one of your points, and then use either point alongside of it. Both of them are equidistant, so either one's fine. If instead of like 150, if it was like 130, I would use that one. Like I would use whatever one is closer. Okay, so that is 400 over 30, as long as I'm doing my quick math correct. So that is 4/3. And think about your units here. This is elevation, and we're in feet. So this is feet per second is approximately how fast we are rising, or the balloon is rising. All right, now for B, we're trying to figure out how fast the temperature is changing at 2750. So the temperature is 49.5 degrees. I did not look to see if this was degrees Celsius or degrees Fahrenheit. And I don't know which one is reasonable because I'm going to be honest, I don't know very much about Celsius. So I'm just going to say degrees for now. So we're at 49.5 degrees. And then again, you can either use this number or this number since each one is equidistant in terms of time. Now, in terms of elevation, which one is closer? This one is 400 away, and this is plus, let's see, 420. Is that what we're adding? To get to 170. So if I add, yes. So the previous point is closer in terms of the elevation. So I'm going to go ahead and use this as my point. So we're trying to say with respect to elevation. So that means temperature, 49.5 minus 51.9 over, and then our denominator would be feet. So 2750 minus 2350. So we're not doing this in terms of time anymore. We're saying with respect to elevation. So this is going to be temperature per foot. So what's the change in temperature per foot? So that is going to be 49.5 minus 51.9. So that's negative 2.46. Okay, why can't I do this math right now? Sorry. 2, it's negative 2.4. I don't know why I was having trouble with that. Okay, negative 2.4 feet. Nope, not feet, degrees. It's either degrees Fahrenheit or degrees Celsius. I don't know. And then 400 feet. So we're in degrees per foot. Okay. So as the elevation goes up, the temperature is decreasing, is what we're figuring out. That's why it's a negative result. Okay, approximately how fast is the temperature changing at 120 seconds? So that's going to be 49.5 minus 51.9 over 120 minus 90. So that's negative 2.4 degrees per 30 seconds. And then you could figure out what that actually is in terms of like just degrees per second. Okay, and then D says, why would you expect the products of A and B to equal C? And the reason is you want to look at your units here. So 4 over 3 feet per second times negative 2.4 degrees for 400 feet. You'll notice your feet cancel, and you end up with degrees per second. And that does work out. What did I do wrong? Oh. Oh, man. Okay. I simplified 400 over 30 in my very first step. It's 40 over 3. 40 over 3. All right, now if I divide this out, I get negative 2.4 over 30 seconds. Okay, now technically, should I redo this video because I made a silly mistake in the beginning? Yes, but just goes to show, yes, you can make mistakes, but if you catch them, nobody will be any the wiser. So yes, I also make silly mistakes constantly, and that is okay. So, yes, I would expect my result from A and B, if you multiply them, to equal C, because your units end up canceling, and then your feet end up canceling, I should say, and then your units end up being degrees per second, which is what my result from C was. It was degrees per second.